So today we are going to discuss a very important but interesting chapter, which is trigonometry. Chapter 8 is all about an introduction to trigonometry, whereas its applications are discussed in the later chapters. So it's very important for you to first understand the etymology of the word trigonometry. It is derived from the Greek words tri, gun and metron. Now I told you that whenever we make use of the word tri, like in triangles, it always refers to the number 3. So tri means 3. So from here you can get an idea that this branch of chemistry specifically deals with triangles, and to be more precise, with right angled triangles. Then gun means sides. So you must have heard about polygon, hexagon, heptagon and so on. So gun refers to the number of sides, and the word before gun, like hexa, penta, it refers to the number of that sides. Then we have metron. Metron means measure. So like you must have discussed geometry in the previous classes. Then you know there that metry comes from the word metron and geo means the earth. So because earlier geometry was primarily used to make geographical measurements. So these three words together give you the word trigonometry. Now, what is it about? So we know that it's dealing with triangles, right angle triangles. So you need to know the three parts of a right angle triangle. That there are three sides first of all. There are three vertices A, B, C. There are three sides. Let me call them A, B and C. There is a right angle. Let's say this is at B, and then you have two more angles, angle A and angle C. So here we deal with the relationship between these sides A, B, C, or you can call them AB, BC and AC, and the angles of a triangle, which is angle A, angle B and angle C. To describe these relationships, we have 6 ratios, which are actually called trigonometry ratios, and sometimes we also call them as T ratios. So there are 6 in number. We have sine, but it is abbreviated as sine, like this. You remove an E. Then we have cosine, from where you remove this I and E. Then we have tangent, from which you can remove this G, A and T. Cosecant, from where you can have A and T cut. Secant, from where you can remove this A and T. And cotangent, from where you can remove this A and G, E and T. So these are the full forms of these abbreviations. We'll be mostly sticking to these abbreviations when we are solving the questions. Then, like any other chapter, what is the use of trigonometry? What are its applications? It's got numerous applications, and earlier it was used by astronomers to calculate distances. Distances between Earth and Sun and Earth or other stars. So for example, this is our planet, lovely planet Earth, and here we have the Sun. Let's say the distance between the Earth and Sun is 1 astronomical unit, and I want to find out the distance between Earth and another star at this point. And we see that together they are actually forming a triangle, as you can visualize from here. Now, how do we measure these distances? Now, it's almost impossible to reach these stars, that too in very little time. So how are we able to make these measurements? Obviously, these measures are done indirectly, and here we make use of properties of triangles, no doubt. But another thing that is made use of is trigonometry. So here if I know one distance, okay, like I know this side, okay, which is the distance between Earth and the Sun. And I know one angle, which is this one, theta, which is 0.00012 degrees. Then these two parameters alone will help me determine this distance between the Earth and this star. So that is the fun part about trigonometry. To make things less complicated, let me give you an example of any monument. Let's say we have Qutub Minar. You know, it's very tall, even if you haven't visited it. And let's say this is our ground, and you are standing over here. Now, just by standing at this point, can you make out the distance or say the height of this Qutub Minar? Well, yes, you can if I give you one angle, one side, because that will be enough for trigonometry to help you out with your problem. So that's why it's used in many places, be it engineering, physical sciences, everywhere we make use of trigonometry. In the very beginning, I told you that the relationships between angles and sides are all about trigonometry ratios, and that is what we're going to discuss in this chapter. And then I told you that there are 6 trigonometry ratios, and I also told them their abbreviations to you. So now we'll discuss those ratios one by one. So let's again look at a triangle. So this is triangle ABC. Can you tell me what is this type of rectangle called? Is it isosceles? Is it equilateral? Is it scalene? Right angled? Well, it is right angle because here you can see this 90-degree angle at vertex B. So here, which side is called the hypotenuse in a right angle triangle? The side opposite to the right angle, and it is the longest side of any triangle. Now, if I consider angle A, this is the side which is adjacent to angle A, which is AB. And what is the side opposite to angle A? That is BC. So these 3 things will be enough to help you find out the relationships between angles and their sides. So here we have sine of angle A. Can you tell me what is the abbreviation for sine? It is SIN. So if I write it in totality in words, I write it like sine of angle A. Otherwise, I can just write it like sine A. Now, what is its formula? It is the side opposite to angle A, that is BC, upon the hypotenuse. What is the hypotenuse? AC. So this is the first ratio, sine A, which is side opposite upon the hypotenuse. Now, one thing that you should ensure here is that sine A does not mean sine into A. Here, sine is a function, okay, like you have f of x, right? So it doesn't mean f into x, it means function of x. So this is sine is a function which is acting on A, where A over here is your angle. Alright. Now there are different possibilities, okay. If I've been given 3 sides in a triangle, I can get different ratios, okay. I can like have side opposite upon hypotenuse, I can have opposite upon adjacent, I can have adjacent upon opposite, I can have adjacent upon hypotenuse, I can have hypotenuse upon adjacent. There are so many possibilities when we are taking ratios of these 3 sides. So can you think how many possibilities are we going to discuss? Well, the answer is 6, and that will yield you your 6 trigonometry ratios, the first one being sine A. Now let's discuss cosine of angle A. Now, if you remember the abbreviation of cosine, it is cos. So I can write it like cos A. Again, it is not cos into A. This is a function cosine which is acting on my angle A. Now, what is its formula? It is adjacent side, which is AB in this case, upon the hypotenuse, which is AC. Don't worry if you're not able to memorize these formulas at the moment, because by the end of this unit, I'll be telling you a mnemonic, a trick by which you can easily remember these 3 ratios. Then we have tangent of angle A. So it's abbreviated like tan A, and this is side opposite to angle A, which is BC, upon side adjacent to angle A, which you know is AB. Then we have cosecant of angle A, abbreviated as cosec A. Now here cosec A is hypotenuse, which is AC, upon side opposite to angle A, which is BC. Now if you remember sine, that is like your primary ratio, okay. In addition to this, if you can remember cos as well, then you will be able to get any other trigonometry ratio that you are looking for, okay. Like for instance, if I want to know the value of cosec, okay, cosec A, it is simply 1 upon sine A. So you take reciprocal of sine and you get cosec. Then we have secant of angle A, which is basically sec A. Its formula is hypotenuse, that is AC, upon side adjacent to angle A, which is AB. Now again, you can get sec from cos, because sec A is equal to 1 upon cos A. Then cotangent of angle A. Okay, it is also written as cot A. It is side adjacent to angle A upon side opposite to angle A, that is AB upon BC. If you know tan, you can get cot from there. Cot A is equal to 1 upon tan A. So this is a summary of what we've discussed so far. Okay. Now these ratios are obviously applicable to only right angle triangles, and the angles that we are considering here are acute angles. For acute angles, all these trigonometry ratios get you a positive value. Okay. But if I change the angle, okay, I hope you know what an acute angle means. Otherwise, I'll just tell you. Acute angle refers to any angle between 0 degree and 90 degree. So any angle between 0 and 90 degree is called an acute angle. Alright, so if this is the range of your angle, then your trigonometry ratios are applicable. Obviously, it has to be a right angle triangle, and then you can get the relationship between this angle and these two sides. Okay, that is what we said in the very beginning, right? That trigonometry is all about the relationship between angles and sides of any right angle triangle. Remember, this angle has to be acute over here. That's why we are getting positive values for all these three ratios. Now, talking about the trick that I told you, so that is SOH CAH So S over here stands for sine, O over here stands for opposite, H over here stands for hypotenuse. Okay, then we have C. C over here stands for cos, A over here stands for adjacent, H over here stands for hypotenuse. Then we have T, that is tan, O over here stands for opposite, and A over here stands for adjacent. So if you know sine, cos, tan, then we saw that what is the reciprocal of sine? That is cosec. Reciprocal of cos is sec. Reciprocal of tan is cot. So if I know these values, called my primary trigonometry ratios, I can easily get the value of cosec, sec and cot. Alright. Now the way to remember sine, cos, tan formulas is SOH, CAH, TOA. But you would be thinking that this is another task. How do we learn this? So many alphabets. So I'll give you a way of remembering this. So consider a girl. Okay, so let's say there is a girl, Sophie. And she has some cats. And she has an aunt. Okay. And her aunt is very tall. Like very, very tall. Okay, and let's say she has orange hair. Alright, now why am I telling you this story? Because that will enable you to memorize the string of alphabets. So Sophie only has, please write this down, it's very important. I know you would be giggling, but this is very important. I'll just tell you its relevance here. So Sophie only has cats and her tall orange aunt. Sophie only has cats and her tall orange aunt. So if you look at the initial letters of all these words, you'll see this is S. What is this? O. This is H. This is C. A. H. T. O. A. Does it look familiar? Well, it should, because this is SOH, CAH, TOA. So if you remember this statement, you can memorize this. If you can memorize this, you can remember sine, cos, tan. If you can remember that, you just take its reciprocal and you'll be able to get the values of cosec, sec and cot. So everything is related. Okay, just remember, Sophie only has cats and her tall orange aunt. That means sine is equal to opposite side upon the hypotenuse. Cos is equal to adjacent side upon hypotenuse. Tan is equal to opposite side upon the adjacent side. And if you remember them, take the reciprocals. Cosec A is 1 upon sin A, sec A is 1 upon cos A, cot A is 1 upon tan A. So at the very beginning, I also told you that if you remember sine and cos, that would suffice. Okay. From there, obviously, you can get cosec by reciprocal of sine and cos by, and you can get sec by reciprocal of cos. But how can you get tan? If you get tan, then obviously its reciprocal will give you cot. But how do you get this tan? So if you have sine and cos, tan will help you. So tan A is equal to sine A upon cos A. Please remember these formulas. They are very important. Remember the 6 trigonometry ratios and this formula of tan A. If you know tan A is sin A upon cos A, I told you what is cot A. Cot A is 1 upon tan A. And if I am saying tan A is sin A upon cos A, if I take reciprocal of this, I'll get cos A upon sin A. Now, how is tan A equal to sin A upon cos A? So, with the trick that I told you, tell me what is sin A. Sophie only has. So, sine is equal to opposite upon hypotenuse. What is the side opposite to angle A? That is BC. Which is the hypotenuse over here? That is AC. Then we have to find out cos A. So, Sophie only has cats and her tall orange aunt. So, cos is equal to adjacent side, which is AB in this case, upon the hypotenuse, which is AC. Now, quickly take this ratio sin A upon cos A. That will give you BC upon AC upon AB upon AC. So, AC and AC cancel out. You get BC upon AB. And what about tan A? What is tan A? So, Sophie only has cats and her tall orange aunt. So, tan is equal to opposite side, which is BC upon the adjacent side, which is AB. And see, tan A turns out to be BC upon AB, and that is what you're getting as sin A upon cos A. Similarly, I'll give you this homework. Put the values of cos A and sin A over here, which you found out already, AB upon AC and BC upon AC, and find out cot A also, and verify if this relation turns out to be true or not. That is a little bit of homework. Work exactly on similar lines as we have worked for tan A. Now, all the trigonometry ratios, all the formulas that we've discussed so far were with respect to angle A. What if I change the angle? Now, mind you, I cannot take angle B because I told you that we are considering acute angles. 90 degree is not an acute angle because acute angles are between 0 and your 90 degree. Okay. Then, let me take angle C. So it will be very interesting to see if the trigonometry ratios will remain the same or will they change if I change the angle. So if I take C, again, Sophie only has cats and her tall orange aunt. So let me find out sin C first of all. So I have to consider opposite upon hypotenuse. Okay, what is opposite to angle C now? That is side AB. And what is the hypotenuse? That will remain the same, that is AC. So we've written the first trigonometry ratio. Now it's your duty to write cos C and then verify your answer with me. Okay, so cos C should be adjacent upon hypotenuse. Adjacent to angle C is this side BC, upon hypotenuse remains the same, that is AC. Now tan C, you can do it like opposite upon adjacent. So it will be AB upon BC, or you could have made use of the formula sin C upon cos C. Okay, so if this is tan C, it cannot be sin A upon cos C. Okay, if it's tan C, it has to be sin C upon cos C. Okay, the angles should not change then. So what is sin C? That is AB upon AC. What is cos C? BC upon AC. So if you take the ratio, even then you will get the same answer. So it could be a good way to verify answer if you have two ways to get to a solution. Then if I know sin, cos, tan, I can easily find out cosec, sec and cot. How? By taking reciprocals. Okay, so I'm having cosec C, that will be 1 upon sin C, and that will become AC upon AB. And what will be sec C? 1 upon cos C. Please write the answer and tell me what is cot C? 1 upon tan C. So sec C, that is 1 upon cos C, it will become AC AC upon BC. Cot C is 1 upon tan C, so it will become BC upon AB. So with this, we've written the 6 trigonometry ratios, and if you compare your results with the previous trigonometry ratios, you'll realize that we're getting different values for the trigonometry ratios for angle C and angle A. That means these ratios will change as we change the angle. Because why will that happen? Hypotenuse will remain the same for angle A and angle C. But what is changing is the side opposite and side adjacent. They simply interchange if I change the angles. Now let's check if the values of these trigonometry ratios of any angle vary with the lengths of the sides of the triangle. So in the previous activity we saw that do trigonometry ratios change with the angle? So yes, they definitely do change with the angle. But what about the lengths? Do they change with the lengths as well? That is what we need to see if the angle remains the same. So here you consider this triangle ABC, the same triangle, right angled at B. Our focus will be on angle A over here. You know that AC is the hypotenuse. Now I want you to take any point P on this side AC and drop a perpendicular on its side AB. Let me drop it at say point M. Then extend this side AC, extend this side AB till point Q and N such that QN is perpendicular to the extended side AB. Alright, so how many triangles do you see right now? I see three. One is this ABC, then we have AMP, and then we have ANQ. We'll make use of all these triangles one by one. So first of all, let's look at triangle PAM and triangle CAB. Okay, what do you notice over here? That this angle M is equal to angle B is equal to 90 degree. Okay, obviously because PM and CB are perpendicular to AB. Then angle AUC is common to both the triangles. So if I can prove any two corresponding angles of two triangles equal, I can say that those two triangles are similar. By which similarity criterion though? AA, which is also called AAA. Okay. Now if these two triangles are similar, what does it mean? That their corresponding sides would be in the same ratio. So that means AM upon AB, the corresponding side AB, is equal to AP upon AC is equal to MP upon BC. Alright. Then again consider triangle PAM. So here, can you write down sine A? What is sine? Sophie only has. So it's going to be opposite upon hypotenuse. What is, if I'm just considering this triangle PAM, what is the side opposite to angle A? That is PM, okay, or MP. Upon the hypotenuse then for this triangle is AP. Again, I'm not considering the whole triangle, I'm just considering the small fragment triangle PAM, okay. Then consider cos A and tan A. So cos A, making use of the formulas, it will be AM upon AP and tan A will be MP upon AM. Now I want you to shift your focus to triangle CAB. Now you have this whole triangle. So what will be sine A now? It will actually change, right? Change in the sense the sides would be different now. So sine A, what is opposite to this angle A? That is the side BC. Upon what is the hypotenuse now? It is AC. Now similarly, making use of the formulas through SOH, COH, TOA, you will be able to get cos A and tan A, and it's your work now to verify answers with me. So cos A should be AB upon AC and tan A should be BC upon AB. Now if you consider these ratios which we got after proving the two triangles similar, we can say that AP upon AC is equal to MP upon BC. Okay, AP upon AC equal to MP upon BC. Now if that is the case, I can, just make a few rearrangements here and there. Like I can take this BC over there, this AP I can take down. So I'll get BC upon AC is equal to MP upon AP. Which means that sine A over here is MP upon AP and here it is BC upon AC. Which means sine A is the same for both the triangles here. Okay, now similarly if I consider cos A terms here, okay, and by this similarity ratio we can say that AM upon AB, this particular ratio is equal to AP upon AC. Alright, again if I make a few rearrangements like here, so I'll get AM upon AP is equal to AB upon AC. So that means cos A of this triangle and cos A of this triangle is the same. Okay, then let's see if the same thing turns out to be true for tan A as well. So for tan A, I'll tell you which ratios to consider. Consider AM upon AB. the first similarity ratio that we wrote down, and MP upon BC, the last ratio. So they are also equal. Again, if you make a few rearrangements, like over here, so you will get MP upon AM is equal to BC upon AB. That means tan A is also the same. So we see that if triangle PAM and triangle CAB, they are similar, then for the same angle A, the trigonometry ratios are actually equal. Okay, and in fact, I'll give you a little bit of homework. Verify the same result with triangle QAN. So first of all, find out if triangle QAN is similar to these two triangles or not. Okay, and let me tell you beforehand, it will turn out to be similar because here again angle A is common, and this angle is 90 degrees, same as angle B and angle M. So by AA similarity criterion, you will be able to prove this triangle similar to triangle PAM and triangle CAB. If the two triangles or of all the three triangles are similar to one another, you will be able to write the ratios like this, and then you can write down sin A, cos A, tan A for this particular triangle as well. And then you'll see that whenever triangles are similar, we are getting the same trigonometry ratio value. It means that the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains the same. So it does not matter. So trigonometry ratios vary with angle but not with lengths, provided the triangles are similar or if the angle remains the same. Okay, enough of theory. Now let's move on to some examples. Now here your Sophie will be very helpful, so please remember her. That will only help you to remember the formulas. So you've been given a triangle ABC, right angled at B, and you have been given tan A as 4/3. Now obviously I hope you understand that this is a ratio, so let's say that the common ratio is K. Okay, because this is a ratio, this is not telling you the exact lengths, okay, of the sides. Like tan, you know, is what? What is tan A equal to? Side opposite upon adjacent. So it's going to be BC upon AB. So it does not mean BC is 4, AB is 3 units. No, this is just a ratio. So let the common ratio be K, and now we can say BC is equal to 4K, AB is equal to 3K, and the units will be only units. Okay, and what is K over here? K is a positive number. Now, if this is a right angle triangle, then I can make use of Pythagoras theorem. Now, what was Pythagoras theorem? That hypotenuse square, that is AC square, is equal to perpendicular square plus base square, that is AB square plus BC square. Okay, now I have the value of BC and AB. Can I find out the value of AC from here? So, AC square is equal to 3K whole square plus 4K whole square. This becomes 9K square plus 16K square. If you add them, you will get 25K square. If you take square root on both sides, you get AC as 5K units. Obviously, I won't take the negative root because the distance can never be negative. So I have the lengths of the three sides of the triangle, because if I have the three sides, okay, then I can easily find out the trigonometry ratios of angle A, because when you are finding out the trigonometry ratios, you need the lengths of all the triangles, of all the sides of the triangle. So now that we have them, using Pythagoras theorem, we can find out sin A, cos A, tan A is already known to us. So first of all, what will be sin A? It will be side opposite upon hypotenuse, that is BC upon AC. What is BC? BC is 4K. What is AC? AC is 5K. So that will become 4/5. What about cos A? It is side adjacent to angle A, which is AB, upon the hypotenuse, which is AC. What is AB over here? That's 3K upon AC is 5K. That's why we had to find AC, otherwise you cannot get the value of cos. So that will become 3/5. So sin A is 4/5, cos A is 3/5. We know tan A is 4/3. Now you need to find out that three more trigonometry ratios, like, right? So that total number becomes 6. So now you tell me what is cosec A, what is sec A, and what is cot A. So cosec A is 1 upon sin A. So 1 upon sin A will become what? 5/4. Sec A is 1 upon cos A. So 1 upon 3 upon 5 will become 5 upon 3. Cot A is what? 1 upon tan A. And what was tan A? It was 4/3. It is given to us. So if you take reciprocal of it, that is 3/4. So then we have been given two triangles, triangles ABC and triangle PRQ. And angle B and Q over here are acute angles. It's obvious that these two are right angles. You can make out from the figure itself. And if they are acute angles, we can write trigonometry ratios for them. It has been given that sine B is equal to sine Q. And you have to prove that the two angles are equal. So first of all, let's find sine B. Let's find out sine Q. So sine B, I'm considering triangle ABC. It will be side opposite to angle B, which is AC, upon the hypotenuse of triangle ABC, which is AB. Now similarly, find out in triangle PQR the value of sine Q. Side opposite over here is PR. What is the hypotenuse of this triangle? PQ. Now it has been given that sine B is equal to sine Q. Alright. So I can say that AC upon AB is equal to PR upon PQ. Okay, just remember this result. And now focusing on these two things again, we can consider this ratio actually to be K. Okay, let's say AC upon AB is equal to K and PR upon PQ is also equal to K. We have assumed this. Now make a table like this, triangle ABC and triangle PQR. Okay, and use Pythagoras theorem in both of them. Why am I able to use Pythagoras theorem? Is it a right angle triangle? Yes. What are the right angles in triangle ABC and PQR? Angle C and angle R respectively. So here AB square, which is the hypotenuse square, is equal to AC square plus BC square, and here I can write PQ square, which is the hypotenuse square, is equal to PR square plus QR square. Now if you make BC square as the objective formula, you get AB square minus AC square. Similarly here you take QR square, that will be PQ square minus PR square. Take square root on both sides. Obviously you have to take the positive root only, distance can never be negative. So this is what you get for BC and QR. Alright, once you have this, you can find out BC upon QR. Okay, so BC upon QR is equal to under root of K square PQ square minus K square PR square. I hope you know that BC is under root AB square minus AC square, and since this ratio of AC upon AB is equal to K and further equal to PR upon PQ, that's why I can write my AB square as K square PQ square and AC square as K square P square R square. It's coming from here. Alright. Upon for QR, I keep this intact, PQ square minus PR square whole under root. Now in this numerator, I can take K square common, and if I pull out that K square, it will become K. So K under root PQ square minus PR square upon under root of PQ square minus PR square. Obviously these two terms cancel, you get K. So what are we getting from here? AC upon AB is equal to PR upon PQ was already true. Now BC upon QR is also equal to K, means that all the three ratios for the corresponding sides of the two triangles are turning out to be equal. So by the converse of basic proportionality theorem, we can say that if the sides are already in proportion, then the two triangles are similar. So this means that triangle ACB is similar to triangle PRQ using SSS similarity criterion. And if two triangles are similar, then what happens to their corresponding angles? They are equal. So here the corresponding angles are B and Q. B and Q can make out from the figure as well as the way of writing the triangles. So angle B is equal to angle Q. Do we stop at this stage? Yes, we finally do, because that is what we had to prove. Then consider triangle ACB right angled at C, in which AB is 29 units, BC is 21 units, and angle ABC is theta. You have to find out the values of cos square theta plus sin square theta, cos square theta minus sin square theta. So for that you need the values of sin theta and cos theta. But for that we need all the three sides of triangle, but we just have two. Can we find out the third side of a triangle? Because it is a right angle triangle, we already know two sides. So Pythagoras theorem will help us find the third side. So in triangle ABC, using which theorem? Pythagoras theorem, what is the hypotenuse of this triangle? AB. So AB square is equal to AC square plus BC square. What is AB square? 29 square is equal to AC square plus 21 square. So AC square will become equal to 29 square minus 21 square. Now you know the formula A square minus B square, it is equal to A plus B into A minus B. So make use of that to simplify your calculations. You can write it like 29 plus 21 into 29 minus 21. Now what is 29 plus 21? That is 50. And 29 minus 21 is 8. So this becomes 400. If you take square root on both sides, you'll get AC as 20 units. So only when we get the three sides of this triangle, only then we can find out the ratio sine theta and cos theta. So here what will be sine theta? It will be side opposite to angle B or angle theta, which is AC, upon the hypotenuse, which is AB. Now AC is 20 and what is AB? It is given to us as 29. So sine theta is 20 upon 29. Then what about cos theta? What is the side adjacent to angle theta? That is BC, and opposite, the hypotenuse here is AB. So it will be 21 upon 29. So cos theta is 21 by 29. Now all you need to do is make the substitution. So for first part, we are substituting cos square theta plus sine square theta. Cos square theta will become 29 upon 29 whole square. The sine square theta will become 20 upon 29 whole square. So this will become 441 plus 400. I can take the LCM, okay, after squaring them up, upon 29 square, which is 841. So that is 841 upon 841, that is equal to 1. In fact, this is a trigonometric identity. I'll just tell you what that means in a couple of minutes. That sine square theta plus cos square theta is equal to 1, and that always is true, always in trigonometry. If you take sine square of an angle and if you take cos square of the same angle, you sum them up, the sum will always be 1. Try it out for any possible right angle triangle, but keep the angle same. Okay, then cos square theta minus sine square theta. So again, let's just quickly substitute the values of cos theta and sine theta in them. So my cos square theta was 21 upon 29 square minus this will become 20 upon 29 square. This is 441 upon your 841 minus 400 upon 841. Take the LCM 841 and here you have 41. So here we get 41 upon 841. You can just see if they are getting simplified any further, and this is your answer. Then you have been given a right angle triangle ABC, right angles at B. If tan A is equal to 1, you have to verify that 2 sin A cos A is also equal to 1. So we are considering this angle A over here. So first of all, if it's given tan A is equal to 1, we are considering triangle ABC. So if tan A is equal to 1, what is tan A formula wise? It is side opposite upon side adjacent. What is side opposite to angle A? That is BC, and side adjacent to angle A is AB. So BC upon AB is equal to 1. Now this means that BC and AB are equal. We don't know the exact value, so let's say BC is equal to AB is equal to K units. Okay, this is also K and this is also K. Then you know the step. To find out sine and cos, we need all the three sides of triangle, but we only have two. No worries, we can make use of Pythagoras theorem because angle B is 90 degree. So what is the hypotenuse here? AC square we will take equal to AB square plus BC square, that is K square plus K square is equal to 2K square. If you take the square root, you will get AC as K root 2 units. K root 2 units. Now if you have all the three sides, you can easily find out sine A, which is side opposite upon adjacent. So it will be BC, upon hypotenuse, upon AC. Now what is BC over here? K. AC over here is K by root 2. So sine A becomes 1 by root 2. Then let's find out cos A. It is side adjacent to angle A, which is AB, upon the hypotenuse, which is AC. AB over here we took as K, upon AC is K root 2. So this is also coming out to be 1 by root 2. Now we need to find out 2 sin A cos A. That will be 2 into 1 by root 2 into 1 by root 2. Root 2 into root 2 is 2. So 2 by 2 is equal to 1. And that is your RHS, and hence we've proven that 2 sin A cos A is equal to 1. Then we have been given another right angle triangle OPQ. The right angle is at P. OP is 7 centimeters. OQ minus PQ is 1 centimeter. You have to find out sine Q and cos Q. So all your focus is on this angle Q. So in triangle OPQ, we can make use of Pythagoras theorem. Pythagoras theorem. So what is the hypotenuse here? OQ. So OQ square is equal to OP square plus PQ square. We already know OP square, which is 7 square. So we have OQ square is equal to 7 square plus PQ square. Now if OP minus PQ is equal to 1, my OQ will become equal to PQ plus 1. This minus will become plus over here. So here if I substitute this OQ equal to PQ plus 1, I can write OQ square as PQ plus 1 whole square. 7 square is 49 plus PQ square remains as it is. Okay, then if I open this, how will I open this? Making use of the formula A plus B whole square. What is it? Quickly tell me. A square plus B square plus 2AB. So this will become PQ square plus 1 plus 2PQ is equal to 49 plus PQ square. PQ square cancels. Take this one on the RHS, it becomes minus 1. So 2PQ is equal to 48, which means PQ is equal to 24. What is the unit here? You won't write units. Here it is given centimeters, so PQ is in centimeters. So PQ is equal to 24 centimeters. Now will you apply Pythagoras theorem again? No, you shouldn't. You can make use of this relation OQ equal to PQ plus 1. Okay, so here PQ is already 24. 24 plus 1 is 25. What will be the units? Centimeter. So OQ is 25 centimeter. So once basically you are able to find the three sides of a triangle, which you will be able to usually by whatever information is given to you in the question, and then you couple it with the Pythagoras theorem, you'll be able to get the three sides of the triangle. And once you have those in hand, you can easily find out any trigonometry ratio. So you have to find out sine Q and cos Q. So sine Q, opposite to angle Q is the side PO or OP, upon the hypotenuse is OQ. So what is OP? This distance is 7 centimeters. Upon what is OQ? 25 centimeters. So sine Q is becoming 7 upon 25. In the meantime, solve for cos Q. What is adjacent to angle Q? The side PQ. Upon the hypotenuse is OQ. PQ is what? 24 centimeters. OQ is 25 centimeters. So with this, you can say cos Q is equal to 24 upon 25.